Okay, we are recording. So as you can see, the Pony Panel class here implements the runnable interface. And for those of you who don't know, maybe I should add a parenthesis there. The runnable interface has this run method. You can pass a runnable object into a thread. You can pass a runnable object into a thread when it's being constructed, and the thread will call the run method while allowing other code to execute elsewhere in the system's memory. So in the run method, as most games have, I have a while loop, while you should not exit, continue to loop. I forget why I have these already did pink variables here. I guess they don't matter. Let's see. I do try to make sure that the images are cached in the tile map, which is the block manager. This is essentially the calculate method, but the method that I'm going to talk about is this, the game draw method, which is effectively the render method. And I do measure how long it takes to go through both the calculation and the render method, and of course painting it physically. And if it doesn't take enough time for a single tick of the clock, then we sleep for a time that's essentially variable depending on how much time was left over. Here I have some code that makes good and sure that the current foreground image is essentially the entire block manager. I've got a catch block here, and just to make sure everything gets cleaned up, I have a system.exit at the bottom here. Anyhow, let's dive into the render method. First, I make good and sure that I have a canvas buffer. This is essentially what I draw everything onto, and in another method, I think it's a paint method or a repaint method that Pony Panel extends. Okay, yeah, it's paint component here. Basically, in the render method, I draw all the game elements onto the canvas buffer, and then in this paint component method, I draw the canvas buffer directly onto the I draw the canvas buffer directly onto the panel. But in game draw, first I make good and sure that I have a canvas graphics. If we're still loading, then we draw this loading screen, which you've seen before. Let's see, if we're showing the ending cutscene that is attached to a goal, then essentially we have this draw the end frame, and it draws that onto the canvas graphics, and again we return early then. Otherwise, we basically run the main method here. Alright, here's a chunk of code that runs essentially if we are in the process of fading the room either to white if the player character died, or black if the player character went through a door. Stop frame is the image that essentially the whole thing freezes on as soon as the character dies or goes through a door. Let's see. Yeah, it's white for death here, black for going through a door, and basically the transparency of this color, the rectangle that we fill it with, depends on how many frames are left. I also have this draw menu if relevant method, which essentially does exactly what it says. Okay, so the very first thing that it does is, if we have a background color, then we completely fill the canvas with that color. And the point of that is to make sure that the out-of-bounds color is there. Let's see, block manager, did I get background? That is the furthest back part of the background, like it's the part that will never scroll at all. We draw that one pretty early on, obviously. So it's like first we draw the out of bounds color, which background color essentially is. Then we draw the farthest back background. Then we look for the background parallax layers, draw those one at a time in order. And each one of these has its own draw method. Might as well dive in. It's going to be pretty simple. In fact, this is going to be one that's actually going to please the code Nazis. There's people who think that a method should be able to fit on one screen. I personally don't believe that. I believe that if a program has a lot of things to do and a lot of decisions to make, then it makes more sense to have it in one big method sometimes than it does to have it broken off into tiny little bite-sized methods. In this case, though, in the case of parallax layer data.draw, there's a small enough amount of stuff to do that it will fit all in one method. So there's a lot of calculation that happens based on the player's X position and the player's Y position. It pays attention to the anchor points that you set in the editor. Based on that, the background image of this parallax layer gets drawn, and then it goes through the whole widget list for this parallax layer data object and draws those. Returning to game draw and pony panel, we iterate through all the background parallax layers, draw each one of them in order. After that, let's see, prime all images except the foreground. I'm a little bit surprised I'm doing this here, but you know, come to think of it, I can't remember a time when I've ever seen it actually do this, so I'm just not going to worry about it for now. The tile map actually gets the tile map actually contains the height and the width of the room. Let's see here. Background, bottom. Let's see here. Oh, that's bizarre again. We have a different place where we draw the background color on. I don't know why we draw the background color twice. Maybe this is something that I missed. Doesn't matter. How much time have I got here? Okay, about halfway through. Okay, so at this point we once again draw the background color, which in terms of the editor is the out of bounds color. Can draw it on the top, on the bottom, on the left side, on the right side, as the case may be necessary. Then, after we have drawn the out of bounds color over top of the background parallax layers, you understand, then we grab the current foreground, which is essentially the image that is associated with the tile map, and draw that. Then it iterates through the background widgets, draws each one of those, iterates through the door sprites and draws each of those. If there are commentary widgets, it draws those. If there are door sprites, it draws those. If there are radios, then it draws those. After that, it draws all the rogue blocks, which includes conveyors, move-in blocks, and any blocks that aren't part of the tile map. Then it draws all the collected items, the boss, the goal. If there are bullets, and these, I believe these are all the player characters' bullets, then it draws those one at a time. Let's see. And I've got this index out of bounds exception catch block because the count of bullets is constantly changing. Then it draws fireball smoke, enemy bullets, fireballs. Actually, I believe that fireball smoke is used both by enemy bullets and fireballs. So I liked the way that the fireballs looked so much that I applied that graphic to pretty much all the enemies' projectiles. After those projectiles, then we get to custom NPCs. That is to say, the custom NPCs that are drawn behind the player. We iterate through all the custom NPCs, just draw the ones that are supposed to be behind the player first here. Then we draw the player character, and you may notice that the player character's position is not passed into the player character's draw method here. That's because I've got the game set up so that the player character is always in the center of the screen. There may come a day when I don't do it that way, but for now I've got it set up so that the player character is always in the center of the screen. Afterwards, we again iterate through the list of custom NPCs. How am I doing? Okay, little time left. We again iterate through the list of custom NPCs and draw the ones that are supposed to be drawn over the player character this time. After that comes the out-of-the-box enemies that are in the process of fading out. There are the out-of-the-box enemy sprites after that. Finally, over top of the enemies, we have items. Then we go through the hurt zones, draw each one of those sequentially. Foreground widgets, those are essentially the animated background elements that aren't in the background. They're in the foreground. They can't interact with the player directly, but they're drawn over top of the player. Then over top of those even we have the rain. If it's raining, then we draw that, even over top of the foreground widgets. After that we have the dialogue display, and that would be drawn over top of the rain, but it's way at the bottom of the screen. And if there is no dialogue that's going to be displayed yet, we call player.draw statuses, and that essentially puts the face plates, the health bars, if you can call them health bars, at the bottom of the screen. Let's see. And the very last thing, well, almost the very last thing that we have as part of the render method is if the player character just died and we've got the screen fading from white into the action continues while we are essentially unfading the screen, or if I should say fading in. And this last bit here is where we draw the death unfade or the door unfade coloring. This is where we fade it in from white or fade it in from black. Again, this is all part of the else block that says, assuming that we aren't dying or anything like that, do all of this stuff. After that, I have this draw menu if relevant class, which essentially decides which images to show. I'm guessing there's some code Nazis who are looking at this code and screaming their lungs out, thinking that it was badly written. Well, maybe it was, but it works, which is probably the last thing that a code Nazi wants to hear. After we've drawn everything, we call canvasgraphics.dispose, and then obviously after the game draw method, paint immediately gets called, and that essentially calls the paint component method immediately and paints the whole thing onto the JPanel. So that's how the overall run block works, that's how the render method works. Next time I'll look at the calculation method.